Hello everyone, how are we doing? So we'll go ahead and look at the post-lab calculations for our experiment 6, which is the limiting reactants. Okay, so in this experiment, you're going to be observing and interpret a precipitation reaction. So let's see what is our precipitation reaction. We have learned what is a precipitation reaction. So in this experiment, our reactants are going to be calcium chloride and sodium carbonate. Both of these are soluble in water. And then when you put them together, we're going to be forming calcium carbonate and sodium chloride. Sodium chloride would be aqueous, soluble in water, and calcium carbonate is the one that's going to be solid, and we want to make sure that it is balanced. So this is our precipitate reaction. So what we're going to do is we're going to use differing amounts of calcium chloride and sodium carbonate, and then we're going to see based on the initial amounts that we're going to get of calcium chloride and sodium carbonate, what is the amount of calcium carbonate that can be formed. Remember how we did examples and calculations when we were talking about the lecture about the precipitation reactions, molar ratios. So we're going to be using all that. Okay. So in this precipitation reaction, we are making the solid calcium carbonate, and then the aqueous would be sodium chloride. We call this as the molecular equation, and when you break them into ions, we have the total ionic equation. This is going to be soluble in water, calcium chloride. Sodium carbonate also soluble in water. And then we can break them into ions, and then we can also form the net ionic equation. So in this reaction, what do you think is the net ionic equation? It's going to be the formation of calcium carbonate. Net removal of ions. So how do you form calcium carbonate? By calcium ions and carbonate ion. So those are going to be involved in your net ionic equation. What's going to be your spectate ions? So whichever end up as aqueous would be your spectate ions. They are going to be sodium plus 1 and Cl minus 1. Okay, they're going to be soluble in water. And then once you make the solid calcium carbonate, we're going to let it precipitate, and then you're going to filter it through vacuum filtration, and we're going to isolate the product. So that is going to be the actual product when you make it in the lab. And we can also calculate the theoretical yield, meaning based on the calcium chloride and sodium carbonate we use, we can find out what is the limiting reactant, and then what is the maximum amount of calcium carbonate that can be formed. And that's going to be your limiting reactant and the theoretical yield. Okay. Okay, so this is how we are going to perform the experiment. First thing is you're going to be using 2 flasks, 125 milliliter Erlenmeyer flasks. Okay, and then first you're going to go ahead and get the mass of their Erlenmeyer flasks. You're going to be needing 2 of these. Okay, and then you're going to get the mass of that. That's going to be your data A. And then you take about different amounts of calcium chloride. So calcium chloride goes to this flask, and sodium carbonate will go to this flask. Okay, so the first trial, we're going to be doing 2 trials, 1 and 2. So for the first trial, you're going to be adding calcium chloride between 0.7 to 0.8. So how you do it is you take a weigh boat, and then you add about 0.7 to 0.8 roughly, and then you're going to put that into the flask. You take a weigh boat, and then you measure calcium chloride about this much, and then you're going to put that into the flask. You're going to take this, and then you're going to put it into the flask, and it's a solid, white solid, so you will see some white powder here. Similarly, you're going to measure the sodium carbonate, and the amount of sodium carbonate is going to be 0.9 to 1.1 grams. Okay, and then the sodium carbonate going to be 0.9 to 1.100 grams. You're gonna another weigh board, you put your sodium carbonate here, and then you measure that amount, and then you pour that into the second flask. Okay, now we have two solids. If you mix these solids like this, nothing will happen, they will just mix it. So what we're going to do is we're going to make aqueous solutions. So to make aqueous solutions, we're going to be adding water. How much water are we going to add? So we're going to be adding 30 milliliters of water. Okay, so you take a graduated cylinder. You don't have to get the mass of the graduated cylinder. We are roughly estimating 30 milliliters. And then you're going to pour it into this flask, and another 30 milliliters should go to this one. And then you're going to dissolve them. You take it and then you swirl it around to make it completely soluble. Okay, so calcium chloride is a soluble complex, sodium carbonate also a soluble complex, so both of these should give you a clear solutions. Okay, and then afterwards you're going to mix them, doesn't matter which one goes to which, and you're going to mix them together, and then you're going to have your Erlenmeyer flask, and you will see a white solid, okay, white particles, and that's going to be your calcium carbonate solid. And in the solution you will have sodium chloride, sodium ion and chloride ion soluble, okay, aqueous. And then once you make your calcium carbonate, you mix it, you let it stand for 15 minutes to make the most solid out of this reaction. And then you're gonna go ahead and filter that through vacuum filtration. You will see all this when you are watching virtual video. So that's your trial 1. And for the trial 2, you're going to be using a differing amounts, another amount, and that's going to be 0.9 to, okay, so the next, for the trial 2, you're going to be using between 0.9 to 1.110 grams, and then the sodium carbonate would be between 0.4 to 0.6 grams. You're going to measure and then put it into the Erlenmeyer flask at 30 milliliters and mix together and let stand, and then you're going to get the calcium carbonate. Okay, so we have 4 different quantities for 2 trials, and then we're going to find out which one is the limiting reactant by calculating the maximum amount of calcium carbonate that we can make with these given quantities. Okay, so let's see how we're going to do our calculations. Now, like I said earlier, after you make the precipitate calcium carbonate, what you're going to do is you're going to do a vacuum filtration. And how do you do a vacuum filtration? Again, you will watch it in the virtual video. So you're going to be using a Buchner funnel. Buchner funnel is a porcelain funnel, and then we have filter papers. It has some holes here for it to filter, and then you're going to put a filter paper. Now before you do this, you want to make sure that you take another weigh board. Sometimes we do use aluminum weigh boards, a weigh board and the filter paper together, and then you're going to get the mass of this. Okay, and then you take that same filter paper that you got the mass, and you're going to put it on the Buchner funnel, and then you hook this up into a side arm flask, the flask with a side arm. Okay, and then you can have a rubber septum here to have a nice shield or nice suction. Okay, and then this side arm can connect to vacuum line. This goes to the vacuum. So under vacuum we can filter our product. So you take your calcium carbonate that was inside your flask. Oh, my flask, look at that. That's not a nice one. Let me draw another one. So you take a flask, Erlenmeyer flask, that you have your calcium carbonate. Better. So you have calcium carbonate, precipitate, and you pour this over the filter paper. under vacuum. So then the filtrate, which is your sodium chloride, will end up in the filtrate, and then the calcium carbonate solid will end up on the filter paper. Okay, and then you let it stand on vacuum for few minutes, and sometimes we use acetone wash to get rid of the water, or else we can take that filter paper with the calcium carbonate, and then you put that in the weigh board, and then you put this in the oven for it to dry. And then after you dry, you're going to get the mass of the product. Okay, calcium carbonate, filter paper, and the weigh board. Calcium carbonate, filter paper, and the weigh board together, you're going to get the mass. So the difference will give us the amount of calcium carbonate that we made from our reaction, and we call that as our actual yield. That is the amount that we make. Okay, and then we can find out the theoretical yield from the given data, and then you can find out the percent yield. So that's what we're going to be doing for the experiment. Okay, so let's see our data. So your data would look like something like this. So this is experiment 6 report sheet that you're going to be using in order to do your calculations, which is already posted on Blackboard. So here we have mass of the empty flasks. Okay, so you can see A is the mass of the empty flask. For the two trials, the first trial 95.338, and then the mass of the flask plus the solid calcium chloride 96.0251, and then the mass of the flask 2, where we put our solid sodium carbonate, that is also given before you add and then after you add. That's your D. And then the mass of the weigh board and the filter paper, that is where we're going to be putting our calcium carbonate, that is 3.1219, and mass of the weigh board, filter paper, calcium carbonate, product measured after product is dry is also given to us. So we have two trials. So you're going to be using trial 1 data to do the calculations for trial 1, trial 2 data to do the calculations for trial 2. Okay, so mass of the calcium chloride used in reaction G. How would you find G? What are the letters we're going to be using? So the G would be mass of calcium chloride is going to be B minus A. So this is a PDF, I cannot write on this one. Okay, so G would be B minus A. Okay, let me do that in the PowerPoint. So G going to be using that data, it's going to be B minus A. And when you do the calculation, you take that value on B, subtract A, and it would be 0.6913 grams. And these calculations, you also double check, don't go by my word. You take the data and do your own calculations. And if you see any mistake, please feel free to let me know so I can let the others know. So I can, do some mistakes too. So don't go by my calculations. You guys also do your own calculations. Okay. So G going to be the mass of calcium chloride. And then H is going to be mass of, H means maximum mass of calcium carbonate. Now this is our reaction. Calcium chloride plus sodium carbonate giving you calcium carbonate solid plus sodium chloride, right? Now we have calcium chloride 0.6913 grams. Now if you use 0.6913 grams of calcium chloride, what is the maximum amount of calcium carbonate that you can make? Okay, so now we're going to do that calculation. That's going to be your H. Okay, for your H calculation, you have to show me that calculation in the space provided in your report sheet, but I will do it here for you. But you put the number that you get at the space for H. Show the calculations in the next page. There you have a space. So you start with 0.6913 grams. What's the next step? So this is the mass of calcium chloride. What should we do next? If you have grams, You have to convert to moles, right? So moles going to be here. 1 mole calcium chloride is the molar mass of calcium chloride, which is again 110.98 grams. And then you're going to use the molar ratio. What's the molar ratio between calcium chloride and calcium carbonate? That would be 1 mole of calcium chloride gives you 1 mole of calcium carbonate, right? So 1 mole calcium chloride gives you 1 mole calcium carbonate. And then the next step, if you want to find out the mass, you're going to convert this to grams. So 1 mole calcium carbonate is the molar mass of calcium carbonate, which is 100.09. Again, so you guys do the calculation for these molar masses. And then H, when you do this calculation, H would come to be 0.6235. 0.6235. Do your own calculations, and if there is anything wrong, please let me know. Okay, so 0.6235 grams calcium carbonate, that is the maximum amount we can make by using 0.6913 grams of calcium chloride. And similarly, for the next time, what we did was we add sodium carbonate, right? So then HI going to be mass of sodium carbonate used in reaction. I going to be mass of sodium carbonate used in the reaction. So which letters are we going to use to find that? So that's going to be I. Mass of sodium carbonate used in the reaction, that would be D minus C, right? Because the mass of the empty flask is 2. Mass of the flask and the solid sodium carbonate D. So that's going to be D minus C. That would be D minus C, and that would give you 1.0862 grams sodium carbonate. Now what we're going to do is we're going to put that number. So we use sodium carbonate 1.0862 grams. Now with this amount of sodium carbonate, what's the maximum amount of calcium carbonate we can make? Okay, so to do that, we start with 1.0862 grams sodium carbonate. And then what should be the next step? Convert into moles. So 1 mole sodium carbonate is going to be the molar mass of sodium carbonate, which is 105.99 grams. And then you use the molar ratio, is 1 to 1. 1 mole sodium carbonate gives you 1 mole calcium carbonate. And then you convert that into grams. 1 mole calcium carbonate is the molar mass of calcium carbonate, which is 100.09. 100.09. Okay, and then with that you're going to get the maximum amount of calcium carbonate that you can make with 1.0862 grams of sodium carbonate is 1.0257 grams calcium carbonate. So this is going to be what I just now did is for the calculations for J. Okay, this is the calculations for J. J calculation. So this is the value you're going to put for J, which is the maximum mass of calcium carbonate that could be obtained from this mass of sodium carbonate. And then the K, the next one is going to be theoretical yield. So with sodium carbonate, we have this amount of calcium carbonate. What this calcium carbonate, we found this amount with this amount of calcium chloride. So we have two numbers, 0.6235 grams and 1.0257. Now we're going to look at which one is going to be the lowest yield from these two. That's going to be the product that we are going to make theoretically. So which one is lower, 0.6235 or 1.0257? Obviously this number over here, right? So how did we obtain this number? By using 0.6913 grams of calcium chloride. So then which one is going to be the limiting reactant? It is calcium chloride, right? So the calcium chloride will be the limiting reactant. So the limiting reactant, the one that you gave the lowest yield, is calcium chloride in this data. Okay, and then the K going to be, what is the theoretical yield of calcium carbonate? So the theoretical yield is going to be whichever the lowest yield out of these two, 1.0257 or this number. So the lowest one number is going to be your theoretical yield, which is 0.6235. So that's going to be lowest of, what are the letters for that? Lowest of H or J. Okay, H or J. And in this our case it became H, which is 0.6235. 35 grams. Okay, that's K. And then the next one is asking what was the limiting reactant. The Ka is the theoretical yield, and then the next one is what is the actual yield, which is mass of the calcium carbonate product actually obtained. How do you find out that? Actually obtained amount, you can see that's going to be L, mass of calcium carbonate product actually obtained. Which letters can we use for that? That is going to be F minus E. Okay, E is the mass of the whey boat and the filter paper. F is the mass of the whey boat, filter paper and the calcium carbonate. So F minus E would be the mass of calcium carbonate actually obtained. L going to be L equals F minus E, and when you do that calculation it would be 0.5623 grams. That's the actual yield, how much we made from our experiment. And then the next one is the percent yield. Percent yield is normally actual yield over theoretical yield times 100. So our actual yield is L, theoretical yield is K, times 100 will give us the percent yield. Okay. So M going to be then in this trial 0.5623 grams over 0.6235 grams times 100 will give us the actual yield, which is 90.18%. That's how you do the calculation for trial 1. And for the trial 2, by following the same procedure that I did with you guys, you can do that your own. Okay. And then if you look at your worksheet, it's asking write the balanced total ionic equation for the precipitation reaction you observed today in the space below. You guys know how to do this one, don't you? So we have done this before. So our molecular equation is sodium carbonate plus calcium chloride, giving you sodium chloride plus calcium carbonate. Solid, aqueous, aqueous, aqueous. Okay, this is how it is balanced. Now this is called the molecule equation, and you need to write the balanced total ionic equation. So for the total ionic equation, everything that is soluble in water, you're going to separate into ions. So sodium carbonate is Na2CO3. Okay, so here what are the two ions we can get from sodium carbonate? That's going to be 2 sodium ions. You can just put AQ. That's how you completely write it. Sodium is positive 1 charge. And then sodium carbonate, and then you have carbonate, CO3 2 minus. That's the anion. And then calcium chloride, calcium going to be plus 2 charge. Aqueous plus 2 chloride, 2Cl minus. That's going to be the other ion. So that's going to be your reactants. And then the products, we have 2 sodium ions, aqueous, plus 2 chloride ions, aqueous, and then calcium carbonate is a solid. So for the solid is going to stay as solid, and we're not going to be writing separated ions. So that's going to be your molecular total ionic equation. And then what are the spectate ions in this reaction? Spectate ions are the ones that you find in both sides, same form. So 2 sodium ions, 1 reactant, 2 sodium ions. And then we have 2 chloride ions, 2 chloride ions. So they are going to be your spectate ions. And then what would be the net ionic equation? So for your net ionic equation, calcium carbonate is a solid. It would be formed from calcium and carbonate. So your net ionic equation would be calcium ions. Net ionic equation is calcium ions plus carbonate ions, 2 minus aqueous, aqueous, forming calcium carbonate solid. That's going to be your net ionic equation. And then use the space below to show your work for the theoretical yield and percent yield calculations. So you can show in the next space in your handout how you did all your calculations for the theoretical yield and then the percent yield. Okay, so that's about it. And then the trial 2, you can do your calculations on your own by following the same procedure. Okay, hope this helps to you, and I'll talk to you later. Bye for now.